Hello, in this video I will be explaining steps for 5 and 6. To get started, firstly we will look into step 4. Fully automatic static routing table configuration. Firstly, we will look into the routing table. So, in the routing table we have destination, net mask, gateway. What is a routing table? In computer networking, a routing table, or routing information base, is a data table stored in a router or a network host that lists the routes to particular network destinations, and in some cases, metrics associated with those routes. What is a gateway? This is the next hop, or the neighboring device's zip address to which the packet is forwarded. What is a net mask? Short for network mask, is a 32-bit value used in computer networking to divide an internet protocol IP address into a network address and a host address. What is a destination? This is the IP address of the packet's final destination. We will open the INI file and the NED file. In the INI file we can see that host 1 is going to have one app and it's going to ping host 7. Then we also set to the code to display the routing table and also the red line to track the movement. As we can see in the routing table router 0, we can see in destination the IP address of host 7. All the configuration is automatic. Next we will see step 5. So in step 5, manually overriding individual routes. Part A, overriding routes to a specific host. In this we assign a specific route from the host to the destination. We will override the routes going from the subnet of router 0 to host 7. So in this example the route that will be followed is as following. Host 1 to switch 0, then router 0, next router 1, then router 2 to switch 2, finally to host 7. To check the route we need to check the XML file. As we see in the program, only host 0 to host 7 is as specified, and not the other way around. Going on to step 5b. So in part B we will override routes going from the subnet of host 02 to the subnet of host 68. These routes will go through router 1. Just as in part A, we will use the step 5b.xml document to specify the path. But similar to the A part, the both packets destined to host 6 and 7 take the diverted route, and the replies come back on the original route. That's for step 5. Step 6 part A. Firstly we will see, what is a metric? It is a measurement used by the routing protocol to make routing decisions. Each routing protocol uses one or more routing metrics to determine the best path from source to destination. Available metrics are the following. Hop count. Hop count refers to the number of intermediate. Date rate. Data rate is the speed at which data can be transmitted over a network. Delay. Delay refers to the time it takes for a packet of data to travel from the source to the destination. Error rate. Error rate refers data packets that are corrupted or lost during transmission. In the XML contains the default rule for IP address assignment if no attribute element is specified. The configurator assumes a default that affects all routing tables in the network and computes shortest paths to all interfaces according to the hop count metric. Let's look at the animation. In part B, manually specifying link cost. This part configures the same routes as part A, but we will specify the route. Host 1 to switch 0, then router 0, next router 1, then router 2 to switch 2, finally to host 7. The routes are the same as in part A, where the data rate metric was used, and routes didn't use the 10 Mbps link between router 0 and router 2. In this part, the link between router 0 and router 2 is turned off by specifying an infinite cost for it.